Now we're going to relearn the same thing over and over because you need to know that when they call it rate of change, it's the same thing. Perfect timing. Rate of change is basically slope. When we called it constant rate of change, that was your direct, we haven't called it that yet. The constant of proportionality, constant rate of change. Now it's just rate of change. It's all part of slope. So, and we know slope is our output compared to input. Output is your y values. Input is your x values. We also call it rise over run. We also call it change in y over change in x. All of these things, all of these ways come back to mean this one thing. We started here. This was our unit rates, constant rate of change. This is K, the constant of proportionality. And then we moved on to non-proportional relationships, like rise over run, which is change in y over change in x. All of these are slope. 2 notes ago, I'm going to turn back 2 notes. 2 notes ago, we found slope using a table where we identified 2 coordinates, found the difference in the y and the difference in the x, and made that a fraction, and then reduced it. Remember this? Slope from a table. That was 2 notes ago. The notes said y equals mx plus b. That. Today's focus is going to be slope from coordinates. We're going to find slope from coordinate. Slope from coordinates. So let's say they give you the coordinates -3, 1 and -2, -2. -3, 1, -2, -2. First thing we're going to do, we have to decide which one is going to be first. Generally, it's the first one. It really does not matter. So first, we need to identify, I guess. Don't want to say label. Your x1 and y1 and your x2, y2. This just means one set, and this is a second set. That's what this little one means. This is your first ones. These are your second ones. It doesn't have any value. It's just like you're going to number them off. Okay, this is the first one, second one, third one, fourth one, x1, x2, x3, x4. It helps you keep them separate. So if I look over here, I'm just going to go in order. I'm going to say, you know what? No, it really doesn't matter. It really doesn't. So this is going to be x1s, x2. This is going to be y1, and this is going to be y2. Step 2. Your formula proper, bless you, is y2 minus y1 over x2 x2 minus x1. Change in y over change in x. So with my y's, I'm going to do negative 2 minus 1. That's negative 2. Yes.
I can't see what that says. Thank you.
You're welcome. And then over x2, which is this one, minus x1. So negative 2 minus negative 3. Notice I went the same direction. You have to go the same direction. If you go from your lefts to your rights, you have to do left to right on both. It does not matter. Yes? Okay.
Wait, why is it 3 instead of 2?
Because that says 3.
But it says y.
All I did was I'm doing y's minus each other, x's minus each other.
Where's the arrow pointing? Yeah, what?
Okay, y2 is negative 2, that goes there. y1 is 1, it goes there. I'm pointing from the first one to the second one. For x2, this is x2 minus x1. You're just subtracting your y's and subtracting your x's. So negative 2 minus 1 is how much? Negative 2 minus 1. Thank you. 6th grade, negative 3. Negative 2 minus negative 3, positive 1. So that's slope. Step 3, we need to reduce and write as proper. Don't make them decimals. If you get 1/4, leave it 1/4. But negative 3 divided by 1 is what? What is negative 3 divided by 1?
Negative 3.
Not a trick. Negative 3. This is slope.